This video is going to cover the plastics topic in Unit 3 National 5 Chemistry. So if we take a few definitions to start with, you need to be aware of addition polymerisation. This is the chemical reaction in which unsaturated monomers are joined, forming a polymer. Remember from Unit 2 that unsaturated substances are those which contain carbon-to-carbon double bonds, so represented with the diagram shown. We also have the definition for a polymer, so both of these definitions will be quite new to you. A polymer is a long chain and it's a molecule formed by joining lots of small molecules called monomers. So if I show you that in a simple diagram form, we have our small monomers, so take 3 and join them together to make a polymer. Now some key things to note here. All monomers have a carbon-to-carbon double bond within them, so each of these will have a carbon-to-carbon double bond. That means they're unsaturated, whereas your polymer, the chain that forms, becomes a carbon-to-carbon single bond. So if this was as carbons instead of just boxes, you'd be looking for this kind of format here. Obviously this isn't an exact molecule because there's no hydrogens or other atoms making the carbon stable, but just to compare the difference between the two. So now if we look at how to name monomers or polymers, so this is very straightforward, so should be an easy mark to pull out for you. So all you have to do is use brackets to compare the two names. So an ethene monomer will form a polyethene polymer. So all polymers start with poly and they end with the monomer name in brackets afterwards. So propene becomes polypropene. If you were to work backwards, so we have polyphenylethene. Don't be put off by any unusual words, it's the exact same principle there. So if you remove the term poly and the brackets, you are left with phenylethene, so that is your monomer name. And sometimes it is like a few words squashed together in the monomer name. Just take care. Normally when you go from unsaturated to saturated, you would think you would change the name alkene to an alkane, so say ethene to polyethane. That's incorrect in this scenario, so as a wee exception to that. So if we look at how to draw polymers out, so you would normally be given a monomer structure, which normally take the structure of a kind of rugby goalpost shape. So you'll have your carbon-to-carbon double bonds, and each carbon normally has 2 things attached to it. So although you've seen propene drawn differently before, this is still propene because it has a double bond and it has 3 carbons with the 6 hydrogens. It's just now been twisted to form this rugby goalpost shape. So if you were given one monomer structure, normally get asked to join 3 of them together to make a polymer. So I would recommend drawing 3 out if you've not been given that already. Now very simple process, easy mark to pick up. For addition polymerisation, you want to break all the carbon-to-carbon double bonds, so you've got 3 to break. Then you want to add the monomers together. Now normally what I would do is draw the carbon chain that will form first. So the carbon chain forms from where you are breaking double bonds. So you'll see we'll have 1, 2, 3, 4, 5, 6 carbons, and they all become single bonds. So there's 6. What we'll also then do is at each end of the carbon chain, we're going to add sidearm bonds. Reason being, polymers are huge molecules, like thousands and millions of chains and carbons joining. You wouldn't ever be asked to draw that many, but you're drawing a section. So no hydrogens go each end here like you would in an alkane or alkene. This just shows you it will continue, and this is a section of it. So if you don't do these wee side parts, you are going to lose a mark, so do be careful. So now what's missing? You'll see we originally had some hydrogens and CH3s. You need to put them back on in the correct location. So if you take one carbon at a time from left to right and put on what it had, you should end up with the correct answer that way. So the first carbon had 2 hydrogens. So the first carbon gets 2 hydrogens. Then my second carbon had a CH3 up the top and a H down the bottom. So this is just a copying exercise, but you need to match it correctly. You can't have drawn your CH3 down the bottom here. It has to be up the top. So if I just continue like that, this carbon gets 2 H's. This one is CH3H. You'll notice a wee pattern forming. 2 H's, then a CH3H. That would be your final answer if you were asked to draw the polymer from the monomers. So now a little bit different. You are given the polymer this time, and you're kind of working backwards, where you're asked to find or identify the repeating unit or the monomers. Could be asked either in this scenario. So here's one example. You see it looks very similar. You've still got your 6 carbons in a chain, sidearm bonds and things attached top and bottom. Slightly different no from what was before. So if I wanted to find the repeating unit, this is the pattern that forms from the carbon chain. So what it will always start as from the start of the polymer. Then you want to find where it begins to repeat itself. Normally it's after 2 carbons. So you'll see C with H and Br, C, Cl, H. So we're not repeating yet. C, H, Br. So then we're starting to repeat. So it stops there. So that what I've circled is your repeating unit. You could be asked to circle it on a diagram, or you could be asked to draw the repeating unit. So if you just draw exactly what's in that circle, you have this. Repeating units have the side arms too. Normally when people redraw them, they might put them in brackets, but it's not needed. You might even see it with a wee N outside to show that it continues in the diagram. So if I was to get the monomer from this, it's easier to spot the repeating unit and then draw the monomer. So if you take your repeating unit, all you're doing is redrawing that, but instead of a single bond, your monomer wants a double bond. So rather than drawing those side arms here, just put the double bond back in. So do be careful the difference between the two. So repeating unit has single bond with the wee side arm bonds, monomer has only a double bond. So one more, because it's a bit of an unusual one. Repeating unit again. So take the first one and check where it starts to repeat. So it starts to repeat here. So repeating unit ends there. So this is an unusual polymer where we have the second carbon doesn't have something at the bottom because it has a double bond up there. So very unusual. It means you're going to have an unusual looking monomer, but that's okay. Don't be put off by strange looking polymers, but it's the exact same process. So if I was to redraw the repeating unit, I have the C with the 2 H's, C double bond CH2 and the side arms. Could draw the brackets round, don't really need to, but they are there. So the monomer, you'll see, redraw that repeating unit with everything attached. Nothing down that one. You see it looks very odd. So not your usual, it's not exactly the rugby goalpost shape, but it follows the exact same concept there. So lots of potential for marks here. You could be asked about the type of polymerisation as well, so addition, the naming of the monomers and polymers, drawing a polymer, or identifying the repeating unit and drawing the monomer. So lots to consider.